Here, the goal. Section 2.3, remember, the first goal, get you the product rule, get you the quotient rule, and then, homework question. So, how would you have solved this for the derivative? Wait, why are we even taking a derivative? There's no, like, word problem saying rate of change, or slope of tangent line, or slope of graph, or velocity. What says? Oh, we learned what ddx is. That's right, and ddx is a verb, and the verb says to do what to this guy? Derive. So the only way that we could derive. Wait. Why am I going to be writing this in black?
Deriving yet.
I'm not deriving yet. What am I doing technically?
Rewriting.
I'm just rewriting? Genius. What?
We should.
Genius. I was meeting at the Starbucks with a friend real quick yesterday after school and before small groups. The one who's out at Moore Park tutoring calculus. The kids have a test tomorrow, I think. They're doing a study session today. And you haven't learned this type of rewriting, but we were rewriting. And I was like, if they don't rewrite it, they won't get it. You gotta remind them to rewrite. I was tutoring the tutor to tutor. Anyway, rewriting. So this is just rewriting. You gotta keep it straight. Just rewriting, not deriving. But once we've rewritten, now what can we do? Hold on, who would we name the derivative? Yeah, we could name it dy dx, or we could just put an equals after that, and that's also good. Because technically this is that Leibniz notation. Remember, he was the one that did the D. Newton was the guy who did the little tick marks, which is good for a little while until it gets old. But dy dx, that was Leibniz. Shout out to him. Wouldn't we just do power rule? Dun 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 dun. Was that impossible? Yeah. Was it a little bit awful? Well, if you don't like boiling, but otherwise it wasn't that bad. But here's the question that we have to ask about. What if you were given d dx of, just pretend it's an x, x squared sine of x. Now what? What's wrong? You can't rewrite it. I mean, you can. X times sine of x. You do something illegal like x squared times sin, and I don't even know what you're going to do. So you have your tangent t over t problem. You're stuck, right? So can you rewrite every single product to be a sum or difference? No, only polynomials. And if I were to put like a square root, like if I was to put a square root here, I couldn't have done anything. If I was to put an e to the, I couldn't do anything. If I was to put an ln, oh, I didn't talk about him yet. Anyway, sometimes we have to deal with a product. Sometimes we have to. And there's no other way around it. Even though rewriting is nice, rewriting does not make any possible function into basic rules only for derivatives. That was really awkward wording, I apologize. Rewriting does not always allow us to just use the basic rules. The basic rules are not enough. They're a great start. And they let us do a lot more than even a lot of you guys thought with rewriting. But not enough. You guys can't tell yet, this is totally going to be a forever time. However, I'm showing you multiple representations, and I don't know which one's going to work well for your brain, so let me go ahead and show you all of them. Let's see. Product rule. If I was taking the derivative of f times g, one way of doing this, and I don't write it the same as all other teachers because I have a little jingle that I'm going to put in the words. So I write it as g of x times f prime of x plus f of x times g prime of x. Other people would technically write it or even solve it, I think including CalcChat, in the opposite order, in the sense of fg prime plus gf prime, or f prime g plus g prime f. There are different ways of doing it, but if you guys notice, good morning. If you guys notice, Addition is commutative, so if it's in the opposite order, it's still okay. Multiplication is commutative. If it's in the opposite orientation, it's okay. So your work might not necessarily be, if you follow this order of everything, might not necessarily be the exact same as the person in the video in the CalcChat or CalcView. It might not be the exact same as the CalcChat work. So the question is it going to match up eventually, or do you have the right pieces and they might just be flipped? Just keep an eye on that. But the reason I like it like this is because you can literally do second function D first plus first D second. The second function times the derivative of the first function plus the first function times the derivative of the second function. Second D first plus first D second. Second D first plus first D second. Where the D is the only place that deriving is taking place. Second D first plus first D second. The second function, g of x, times the derivative of the first function, f prime of x, plus the first function, f of x, times the derivative of the second function, g prime of x. Other notation. And this is one that is nice as far as being able to show you guys, hey, oh, he's not see-through. Party pooper. That's okay, we'll go make him see-through. If you were looking at a function, there's going to be multiple times that you guys see me basically trying to call you out and being like, did you realize it had to be a product rule? Because you know how you guys were making up some stuff, and maybe you didn't, but other groups did? I don't want fill color. There's no none option. How do you do none if you don't want none? Oh, I'll do it this way, even though it's awkward. That works, even though it's weird. Okay, when we were doing those basic rules and you guys had the whiteboards for the first time, some of you made up really illegal rules. And you were like, yeah, this works. And I'm like, no, it doesn't. You're going to try to do illegal stuff with product rules, too. Just because you know some stuff and the some stuff you do know, you're like, I can use it over and over and over again. At least I hope so. And it's not always necessarily true. I can't prove it because it's in the background. Anyway, that's all right. Good enough. So when I do box and triangle, what I'm trying to show you is it's a product of two separate functions, and products of two separate functions need the product rule. And here's how the product rule works this way. You can do triangle, d-box. Triangle. Hold on. Not like Mr. Shea. I need to plug in this time. Get that at the board. Plus box triangle. You know, it's silly, and some of you might be like, that's the dumbest thing I've seen in the world. Like, why are you doing shapes for functions? But believe me, it helps some people. So, product rule. Second D first plus first D second. You're taking the derivative of it, but you have to take the derivative piece by piece in a very particular formulaic way. Product rule, how to derive any product. So let's take that original function that we had just a second ago. Let me see if I still have him. No, I don't. Number 12. What? Oh, sorry, yeah, forever 12. Forever 12. Let me get rid of this guy for just 1 second. We're going to go back to this guy and say, okay, how would we solve him now that we know the product rule?
First, second.
Math that. It's not really a plan, but it does kind of have a burst to it. I guess we could make it a, what are those poems that Miss Lee does?
Slam poetry?
Make a spoken word, all that kind of stuff. Anyway, coming back. With the product rule. Wait. So look, I have a first, and I have a second. So, how would this work? It's up to you, but if I were you as your first learning it, I would write whatever representation seems to make more sense to you. You can call that F and that G. You can call this literally first and that second. You can call this box and that triangle. So either way, we're trying to do second be first plus first be second, which is going to take us to, for our dy dx, 3x minus 7 times d first. I was trying to get you really good at the basic rules so that you can do this mental math style. What's the derivative of 2x squared plus 1?
4x.
4x. Plus first d second, which would be 2x squared plus 1 times the derivative of 3x minus 7 is just 3. Yay, it's the same thing. No, it's not. Yes, it is. But what do you have to do? Distribute a little bit. So as you distribute, you would end up with over here a 6x squared. I'm collecting all my terms. It's super dangerous. Please keep track.
Whoa, Miss T.
But I have my 6x squared over here. I have my 12x. Over here, I have my negative 28 and my plus 3, which would be negative 25. Ooh.
Maybe you should go a little slower, Miss T.
It's 12x squared.
You forgot the 4x.
Yeah, we're at 4x.
The 4 times 3.
You guys have to be careful of your basic rules. Second d first wasn't just 4, it was 4x.
Oh,
Careful, some of you are good. But are you that good? You're going to be doing derivatives with mental math.
You just jumped.
Take it slow, take it slow. But now I have my, here we go, it's a little bit better, right? Because I have a 6x squared and a 12x squared. 6 and 12 makes 18x squared. Oh, this is looking bad. And then I have my 28x. Looking for my constants, and I have a plus.
What?
So, you guys, ready, set? Oh, no, keep going. Derive. No, I want to multiply. We'll have fun with that. The trinomial and the binomial. Go team. If you want to rewrite, go for it. But I'm going to use the product rule and let's see who wins.
I will win.
Although I'm giving you a little bit of grace to write down.
Thank you.
Is it a speed competition? Not necessarily, but those of you that are like, I can do derivatives, why not have some fun with it and try to beat me? But for others of you, just go slow and steady. For you, it can win your race. Your race is not everyone else's
I have a
race.
question. Don't you have to write it like that? Like in ascending order? The problem?
Oh, just because I learned that. I think I stole it from someone. Sometimes, no, this is the thing. Sometimes, and you guys have seen this before. Sometimes instead of going in descending order, because it's awkward, they go the opposite way because of the negative. Check it. They're going the opposite way because of the negative. I'm just saying. And then since that one was the opposite way, that one's the opposite way. Makes it more fun.
Yeah. Okay.
Okay, I'm going.
What did you just do?
I was trying to select it so I could move it so I have more space.
Oil.
Well, if it was a long answer, you could box it and be done. Stick it to the middle. If it was long. But don't we? I'll tell you, this would not be long. In which case, for right now, I'm caring whether or not you're getting it right. But don't we eventually have to make it match with the odds on the back of the book and the multiple choice question that it would actually. Okay, so is it a bummer? Yes. Do you still have to do some foiling? Yes.
Okay. I have made it. I think it's X to 7. I don't see that. I don't know. X to 8.
Yeah, it's 7.
Isn't it a fifth power? Oh, fourth.
Use your mind.
writing. Well, on the smart board stuff gets squished in it, so.
Right.
Better combine, that's nice.
Boom. Happy.
Yeah, you do. So the smart board we should see. Just kidding. My job isn't personal excellence. I mean, it is in some ways, but how to make it.
That was really wow. That hurt my head.
Because my job's not about me, it's about you, right? Technically.
You've been competition anyway.
Some of you guys, come on. I feel tentative. Give me my own whiteboard now.
What?
Doesn't matter. How are we doing? Could you have foiled that whole, well, do you even remember how to foil? I'm trying to know if Don't you have to distribute just everybody to everybody? So you just go, hey, he's first and second, and hey, he's first and second, and then hey, he's first and second, and then power roll, power roll, power roll. Would have worked. Would have worked. But once again, we've done things that are technically optional so far, right? Are there times when it's not optional?
Oh yeah.
If it's not optional, there would have been no way to rewrite. So you would have just had to go for it. There's nothing else you can do.
Well, sorry, because
It's not going to make that product, though, into something. Okay, so product rule. Sometimes it's optional. Usually it's not. But it's something we definitely have to have in our arsenal of derivative rules. But there was one other rule, and we're probably not going to practice this rule today. Because we do need to get to grading our homework. We're not going to practice this rule today, but I am going to go ahead and write it out so that you have it. You can put it in your forever cards, and if you are brave enough to tackle homework, you did the product and quotient rules in the summer packet. It's not for him.
okay.
You can. This one, guys, even though product rule, it's like, yeah, multiplication, addition, no big deal. It can be all switched around, technically. I just like the second D first plus first D second. It has a nice little ring to it. Quotient rule, not optional. The order is not optional. At least not in the addition way, because we have subtraction, not addition, and subtraction is not commutative. These two can't be switched. The bottom, D top, this can be switched. I could do D top bottom. It's just, I don't like the ring of it. I like bottom D top much better. The multiplication can be commutative, but the subtraction most definitely cannot. Minus top D bottom. All over bottom squared. You guys notice I just gave you the words. Bottom D top minus top D bottom. P.S. the capital D is another way of writing ddx, and technically we would show the little x as a subscript. Differential x with respect to x at the top and the bottom. Anyway, just a snazzy way of writing it. All over bottom squared. Or with our notation, if we were to take our box and triangle, we would be bottom D top minus top D bottom and the bottom squared. Bottom D top minus top. And And that's when looking at a quotient as being a f of x over a g of x. A top over a bottom. Now, technically, we all know we would call these numerators and denominators. Yeah, I know, it's snazzy. Good job. We're just trying to make it easy and memorable. Quotient rule, forever card number 13. It's a thing. All right, guys, color pens and homework spirals. We've gotten what I meant to do, which was getting you the product rule, getting you the quotient rule, giving you an idea of my notations on these forever cards. That's not helpful to you. Let me keep this for one more second as I go. Get the right tab with your homework so that we can grade 2 to B. How scary were the words last night? Ah, come on, after class yesterday? Just kidding, I'm not roasting you because I know everyone wants to say scary. I'm just hoping there would be at least one or two that were like, eh, not as bad as I thought. Thanks, bud. Oh, come on, computer. Why are you frozen? Oh, struggle. Come on. Wow. Okay, here we go. Homework. It's going. It's just barely going. All right. Number 92. Your final answer should have been 0.955. No! You should have gotten 3 over pi. That would not have been a calculated problem. You got a decimal.
Oh, I actually.
But what they're trying to tell you is sometimes you might get stuff in a different form, and you can always plug it in your calculator, compare it to the decimal equivalent of the book, and see whether or not it works. We talked about how answers can show up in different ways. However, that was the average rate of change. You were also supposed to find the instantaneous rate of change. Yes, the decimals are to make sure that you match, but not for what you should have been doing. You would have written the exact answer, written the exact answer. F prime of 0 is, 1. I didn't show you both. So you have the derivatives at the endpoints, and then you have the average. They ended up kind of being pretty close to each other. No drastic change. Number 96 was one of those ones where you were using the equation from the bold print up above. You would have plugged in and gotten this to be your position function. You would have taken the derivative and gotten your velocity function. You would have plugged in to find the velocity at 3. And then you were supposed to find the height this was the clue. After falling 108 feet, you were supposed to find your velocity, which is negative 86 feet per second. Sorry, there are all your answers. What's the position, the velocity, or velocity after 3 seconds, and what's the velocity after falling 108 feet? Here's the weird thing. Did you guys realize after falling 108 feet, your position, so you fell 108, but your position was 112. If you got a little bit off, if you fell 108, you are 112 off the ground. So you weren't supposed to plug 108 into position, you were supposed to plug in 112 to your position. And if you guys notice, they actually plugged in 112, subtracted it to the other side, and then they were able to solve for the zeros with factoring. You didn't need a calculator. They figured out that that happens. It's fallen 108 when t equals 2. Plug it in, plug it in. Some of you are like, yeah, that last one was hard. I get it. I know. It's a question for us to cover when we have a chance, okay? Anybody want to? No, it's on the video. It's on the video. I'm going to erase it in a second, so. You can go back. You can slow me down. You can pause it. You can ponder it if you're like, I'm so lost. Remember, 98 was another one where they gave you the formula. And this one, the final that you were looking at was when the velocity was equal to 0. Which is going to happen when t equals 5.6, and your position when that occurs is 133.7. I think you were looking probably for your maximum height. Oh no, when it hits the ground. What was it? Oh, the height of the building. Oh, they didn't give you S, and you had to find. Oh, that was interesting. But it was dropped, which is why this guy disappeared, because remember, dropped means your initial velocity is 0. So that's why that guy just goes away. He's not a part of it. We knew that it hit the ground after 5.6 seconds, so we can set the position equal to 0 when t equals 5.6 seconds, and then they just have to solve. Hit the ground, I got to set position equal to 0. My initial velocity dropping made it 0, so all I needed to search for was plug it in. Little guy I was missing. Number 102, you were supposed to be graphing what the derivative showed. So the derivative showed, if I'm not mistaken, a constant velocity of, let's see, up to over 4. So a constant velocity at 1/2. And then it showed a constant velocity at 0, because the slope is 0. And then a constant velocity of up 4 over 4, so then it would go to 1. Were you given something like that as a graph? And then you were supposed to say, hey, it's going up 2 over 4. It's going up a slope of 1/2. And then it's going a slope of 0. It's going flat. And then it's going a slope of 1. It's going back up. Might not have been perfect, but you should have had the idea of going up and then going flat and then going up even steeper. Oh, and that was all the evens? Okay. Guys, please hear me. I'm not saying that anything I just went over was easy. Section 2.2b, as far as concepts, is one of the heaviest sections that you've seen thus far this year, as far as application of the derivatives. And so I realize a lot of you guys got stuck probably in something like 98. The graphs are still kind of tricky and still kind of iffy. So I realize you might have gotten stuck there as well. But to be honest, if I even try to go over homework questions in 2 minutes, it's not going to be effective. So, do you have stuff marked on homeworks 2.2a and 2.2b that you probably should ask about? Yeah? Okay. I want you guys to go ahead and then kind of get those fleshed out a bit tonight in the sense of, I really need this one. Like, I really don't understand that one. We're going to start tomorrow with homework questions. Cool? Hold me to that. Make sure I don't decide to do something else. 11, 12, 13. But the end class, instead of half doing a homework question that's not really going to be effective, homework questions 2.2a, 2.2b, have them ready tomorrow. We might get people up to the boards and actually have you guys discussing, collaborating, talking through where you're stuck. Word problems, all problems, all fun. Let's do a quotient rule one. So, what's the quotient rule tell me to do to finish or to take this derivative? Do I have a top?
Yes.
Yes. Do I have a bottom?
Yes.
Yes. Read me the words, because that's what I'm going to use mostly in class.
Bottom.
What am I supposed to do? Bottom?
Bottom.
I rewrite. D top? Minus top? D bottom? All over bottom? Squared. What would you need to do? Name of the game is simplify and make it match. Get out of here, quotient. See you later. Start your partial quotient rule. Concept-wise, it's a lot lighter. It's a lot lighter. Have those homework questions ready. Good job, kids.